Okay, photochemistry lecture 6 that should be concerned about Paterno Buchi reactions. Paterno Buchi reaction, that should be a special type of reaction occur in presence of photon energy or H nu. Okay, that should be considered reaction in between of carbonyl and alkyl. Okay, so when we consider photochemistry, we have to study about Paterno Buchi reactions. So, Paterno Buchi reaction, the reaction involving 2 plus 2's photochemical cycloaddition between an electronically excited carbonyl group and a ground state olefin group, that should be yielding an oxytane. Oxytane is the adduct of excited carbonyl and olefin, or you can say better, that is the compound produced from excited carbonyl group and a isolated alkene. Okay, that should be termed as oxytane. So there should be, we need one carbonyl excited and ground state alkene. So they react and they in presence of H nu produce oxytane, this type of compound, oxytane. So there should be 2 plus 2 cycloaddition, this and this, and by this way they produce this oxytane. Okay, so this reaction is known as Paterno Buchi reaction. Now, Paterno and Chipi discovered the photochemical formation of oxytane, and Buchi in man and Lipinski carried out the initial investigation into its mechanism. Okay, so Paterno and Buchi all give their contribution to discover Paterno Buchi reaction. For their contribution, the reaction is named as Paterno Buchi reaction by using their names. Okay. Okay. Now consider there should be in definition we get 2 plus 2 cycloaddition. Okay. So we first of all we know that cycloaddition is this type of reaction. 2 plus 2 cycloaddition means what? Suppose 2 alkene and that should be react this type of, this is called cycloaddition, that is called 2 plus 2 cycloaddition. Okay, when you consider that is this, okay, this is termed as 4 plus 2 cycloaddition. Okay, so as we know 2 plus 2 cycloaddition is thermally forbidden, and now that is thermally forbidden and photochemically that should be allowed. Why? Because when we consider for cycloaddition is nothing but reaction of HOMO of one component and LUMO of other component. Okay, when we consider 2 ethylene that should be combined to each other, so they produce 4-member ring, right? But on that case, if they are thermally allowed, so their HOMO and their LUMO that should be interact with each other. So their HOMO is this is their HOMO of ethylene, and this is should be LUMO of ethylene when we consider thermally. Okay, so their phase is defined because this is E plus and this should be plus, this is plus and this should be minus. If we consider as red color is plus one phase and blue color is minus phase, so on that case their phase are not overlap properly. Okay, like for example if their phase like that, okay, now So there should be bonding interaction, there should be anti-bonding interaction. Okay, there should be bonding interaction, okay, and there should be anti-bonding interaction. In this region, anti-bonding interactions are there. This interaction is anti-bonding in nature. So by this way, thermally are not allowed. But when we consider H nu, that is photochemical, on that case, this is act as HOMO as well as this is act as, on that case, suppose there should be, there the two electron excited and go in that place. Okay, when H nu is used, okay, one electron get excited and go to the higher excited state, and higher excited state means pi star. So there should be one phase like this, and other phase that should be like this. So there are both of cases, there must be bonding interaction. Bonding interaction. In that case, for excitation, that is HOMO considered as pi star and LUMO also considered as pi star. And pi star overlap for ethylene is effective as their phase can be matched. So both of cases we get bonding interaction. Okay. Here, after excitation, when we use H nu, so pi star is considered as HOMO of one ethylene and pi star is considered of LUMO of other ethylene. So there should be perfect overlap. So bonding can also be permissible. So cycloaddition, 2 plus 2 cycloaddition is favorable when photochemically we perform, otherwise not. So that's why there should be maintained 2 plus 2 photochemical cycloaddition between an electronically excited carbonyl, because carbonyl group that should be excited. Okay, there should be excited and there should be electron promotion can be take place. So that's why excited carbonyl group and also ground state olefin. So the reaction produce oxygen. Oxygen means this type of compound. This is called oxygen. So we get the reaction Paterno Buchi reaction. Now consider the carbonyl functionality may be aliphatic as well as aromatic. Aliphatic means there should be any type of non-aromatic alkyl group, cycloalkyl group that should be present. And aromatic, there should be aromatic compounds are present. Okay, aldehydes of ketone or also of quinone also. Okay. And the pioneering example of this type of reaction is the photocycloaddition of benzaldehyde, that is PHCHO. That is must be, we can say there should be benzene ring, that is CHO. Okay, this is. This is benzaldehyde with 2-methyl-but twin. This is. And carried out by Paterno Buchi 1909 using UV light, and the less substrate end of the C-double-bond-C ends to the carbonyl oxygen due to steric factor. Okay. Always remember there should be oxygen having 2 lone pair. Okay. Okay, 2 lone pair. So always oxygen go on less substituted end. Okay. So this place go this side. As in that case, electron density is higher due to 2 methyl group. So that should be react with carbonyl carbon, which is more positive. By this way we can say this is more favorable, as well as due to two reasons we get, that is due to two reasons we can say that is oxygen attached with less substituted carbon. Because of steric factor, oxygen having two lone pair, there should be lone pair bond pair repulsion. Due to avoid this interaction, oxygen always attached on the less substituted side. Okay, this is the main reason. And for specifically in that reaction we can consider also other reason. They are basically in the more substituted carbon having two methyl group, and methyl group always show plus I effect, plus inductive effect, and increase electron density. So it is more favorable, that is more substituted carbon attached with the carbonyl carbon rather than carbonyl oxygen, because carbonyl carbon is more positive character. So always remember, negative part can be attacked to positive part. So more substituted carbon having more electron density, so it basically attack to carbonyl carbon, which is more positive. This is the second reason you can say for specifically this type of reaction. But this is not always used. But for Paterno Buchi reaction, the main reason is oxygen always go to the less substituted carbon because of due to steric factor, to avoid lone pair bond pair repulsion. As we know, lone pair repulsion is more than lone pair bond pair and bond pair, and lone pair bond pair repulsion, that should be more than bond pair repulsion, right? So avoid this lone pair bond pair repulsion, so oxygen always go to the less substituted part. This is the main reason for Paterno Buchi reaction. And what I derive, this is for particular this reaction. Okay, that due to inductive effect, this more substituted carbon is more electronegative, so basically it's favorable, it react to the carbonyl carbon, which is more positive. But this is not always fruitful for all of the reaction. But the main reason that the oxygen always attached to the less substituted carbon, this is always maintained. Okay. Now, however, those carbonyl compounds that undergo rapid Norris type 1, that is cyclobutanone, and type 2, that is 5-methylhexane 2-on reaction, would relatively be unsuitable counterparts in Paterno Buchi reaction. Okay, they are always show Norris type 1 and Norris type 2 reaction, but relatively be unsuitable counterparts in Paterno Buchi reaction. Examples are basically benzaldehyde react with olefin, we produce this type of compound. This is the major because this part is less substituted. This part is less substituted. Okay. And here also same, that is react with, there should be both sides same substitution, so there must be no confusion. So in any side oxygen can be attached. This, okay. Now consider when we introduce electrophile positive, we get this side. Okay, because when electrophile attached, electron mean positive, there should be any negative attached, one bond is break. Okay, and that is must be when you use nucleophile, when you use heat, sometimes it also be produced. Okay, now these are the very important examples of Paterno Buchi reaction product. This is used as insecticide, this is used for antibacterial agent. Okay, this is used for antibacterial agent, this is used for insecticide. Now we consider mechanism, that is N and pi star. N is the non-bonding, that is must be ground singlet state, this should be excited singlet state, this should be excited triplet state. Okay, so this is ground singlet state having two electron that should be paired up and their spin are opposite, so their overall spin that should be cancel out each other, that is plus up minus up 0. So overall spin multiplicity for S0 1. Okay, now when one electron get promoted, we get this. Okay, S1. S1 is a excited singlet state. S1 is a excited singlet state. So there should be also spin are not change. So plus up minus up 0, but two orbital or two state having two defined electron. Okay, and on that case spin multiplicity also 1. Now when spin change T1, their spin multiplicity and overall spin that should be changed. Overall spin plus up 1 and overall spin multiplicity that should be 3. That's why it is termed as triplet, excited triplet state. Okay, now consider that is this is ground state S0. There should be by absorption it go S1. There must be inter-system crossing, we get T1. Okay. Now this is carbonyl. There must be light induced, so homolytic fission can be there and produce this type of configuration. Okay, that is homolytical means that is this must be 1 electron, this should be 1 electron. Okay, one bond that should be break and oxygen and carbon take their 1 electron each. Okay, so we get this type of configuration. Now they get excited and there should be the other 1 electron go this side. Okay, this 1 electron go this side. Okay, you can say better. There should be homolytic fission. Okay, so now we get this and there must be 1 electron go this side. So we get there should be 2 electron and there should be 1 electron. Okay, similar energy if we draw this, that is 1 electron go this side. Now this orbital having 2 electron. This is called excitation of carbonyl. This is called excitation of carbonyl. Now homolytic cleavage is there both sides, so there should be oxygen attached to the less substituted carbon end, and by this way 2 radical produced and these 2 radical combine to each other to produce oxy 10. Okay, similar analogy, that is homolytic fission, then the oxygen attached to the less substituted side and then 2 radical produce and they combine by this 2 way and 2 product can be formed. In one case, as there should be radical is formed, so single bond rotation can be possible. So methyl group in first configuration same with respect to other methyl group, and in that case the methyl group is opposite configuration to the other methyl group. Okay, if there must be, suppose 1 radical is produced, suppose there should be a 1 radical, so there should be single bond rotation. So by this way it can be convert this side. Okay, so by this way with 2 product we get. Okay, then the another example, that is react in presence of light. So this product first form, again there still 1 alkene is there and pH2CO is large in excess. So other pH2CO again bind and again we combine to produce this type of compound. Okay, next one, there should be homolytic cleavage. By this way 2 radical combine, okay, and then produce this type of combination by this 2 analogy, that is there these 2 radical combine and produce this, and in that case these 2 radical is combined, these 2 radical is combined to produce this compound. Okay, if there is present two radical and there is present two radical, this must be combined this way or this must be combined this way also. Okay, suppose there must be radical, there must be radical, they can be combined to produce this way, or there must be radical, there must be radical, suppose there also a radical generate, so they can be combined. Okay, by this two analogy we can say there should be so many possibility of recombination of radical, because more than two radical are produced. So in that case, first these two radical are combined to produce this type of configuration. There should be, this is the possibility to recombine two radicals, so we get this product, and there should be other possibility, so we get this product. Okay, okay, up to this. Now so what is the summary Paterno Buchi reaction? Paterno Buchi reaction is nothing but it is a 2 plus 2 cycloaddition, photochemical cycloaddition of excited carbonyl group with any olefin group. Okay, and that should be observed by Paterno and Buchi. Due to this naming, we get the overall name of the reaction Paterno Buchi reaction. So 2 plus 2 cycloaddition is a cycloaddition that should be only possible in photochemical point of view. This is unfavorable for thermal condition, because when thermal condition is thermal condition are applied, on that case 2 alkene or 2 olefin show their combination of HOMO and LUMO. Okay, one HOMO is pi, another LUMO is pi star, and HOMO and LUMO of olefin are defined phase. Okay, so there should be in one case suprafiscal interaction, in other case antifiscal interaction. So one is bonding interaction, other is anti-bonding interaction. So on that respect to this, the interaction is not favorable. But when H nu are used, on that case photochemical excitation of electron can be performed. So one electron goes from HOMO to the next upper excited state, that should be pi star. Okay, now for one olefin, the olefin that should be excited having their HOMO pi star, and the other ground state olefin having their LUMO pi star. So both of two having the same phase, because HOMO and LUMO now both are pi star. So due to this, two pi star are combined easily as their phases are matched, as their bonding interactions are can be seen. So due to this, photochemical cycloaddition of 2 plus 2 cycloaddition, or photochemical 2 plus 2 cycloaddition of carbonyl and olefin, that should be favorable. Okay, in that case, in Paterno Buchi reaction, carbonyl group is excited and olefin that should be belong to ground state. Okay, but when we observe their substitution, their mechanism, okay, so we get two important points. One, that should be oxygen always attached to the less substituted carbon atom, because due to steric effect. Okay, and second one, there should be homolytical fission. Homolytic fission, and two oxygen attached to the less substituted site, and then two radical formation, and due to recombination of these two radical, we get the ultimate product. Normally oxygens are the product, but sometimes other product can also be formed. Okay, and there should be, always remember, oxygen can be react with Nicophile, electrophile and heat. Okay, they produce various type of product, and even when the compound having two olefinic part or two double bond, they can be perform Paterno Buchi reaction twice also. And in that case, we learned that is H0 is the ground single state having two unpaired electrons. They should be paired up and their overall spin is 1. So that's why it is termed as singlet, and overall spin that should be plus up minus up 0. Then when one electron promoted to higher excited state but a spin that should be unchanged, so they are unpaired but their overall spin are not changed. The overall spin still 0 and overall multiplicity still 1. So the name is termed as singlet but excited singlet. Okay. But when spin change, when the excited electron change their spin and go the upper excited state, so on that case the overall spin also change, that is plus half 1. So we get spin multiplicity 3. So that's why we tell that is excited triplet state. Okay. Now when carbonyl are excited, there should be first step, that is homolytic fission. Oxygen and carbon both take their own 1 electron each. Okay. Now second step, oxygen give their 1 electron to the carbonyl carbon, and carbonyl carbon having 2 electron. Okay. And then we can term it as carbonyl is excited. And this excited carbonyl react with olefin. By this way, oxygen attached to the less substituted carbon atom, and then 2 radicals still there, and then these 2 radicals can be combined. Sometimes some rearrangement can also occur, then recombination can be occur. So by this way we get products. Okay. This is termed as Paterno Buchi reaction. The mechanism is sometimes defined then the other chemical reactions, because other chemical reaction there is not so much considered about radical. Okay. As there is radical is formed, so on that case single bond rotation can be there. So before recombination there should be still single bond rotation can be possible. So we get 2 defined orientation of methyl in that reaction, 2 defined methyl group orientation due to single bond rotation. Okay.